Highly hope. Mr. Kaczynski here. Going to go through the second part of the Chapter 4 test, Standard 4B. Here we go. It's kind of lengthy, so let's just get right after it. All right, what is the slope of line A here? So line A is this one going down here. I can see it starts right there, goes down one, and right one before it hits the line again. Down one, right one, down one, right one, so on and so forth. So the slope is -1 over 1, which we always would just simplify to -1. The y-intercept of line A, that's the point where I started right up here. It's this is 0, 1, and 2. So that's going to be at 2. And then the equation of line B. Well, line B has a y-intercept of -2. And it's got a slope of, looks like up 1, right 3. So we'll put plus 1/3. So how about y equals -2 plus 1/3 times x. And the point of intersection, that's kind of a gimme, isn't it? Right here where they cross. 1, 2, 3 to the right of the origin and 1 down. So 3, -1. All right, there's our first few problems. Getting some point slope here. Name the point on this line with an x-coordinate of 3. All right. So y equals 7 minus 2, and then we'll put 3 into that. And that'll give us the y value. And then we can write the point. So we could use mental math. 3 minus 5 is -2. -2 times -2 is 4, and 7 plus 4 is 11. Or we could punch it into the calculator. There's any number of ways we could get this value. But you can see that when x is 3, y is 11. So the point is 311. Name of the point on the line with a y-coordinate of 5. So now we're putting 5 in for y, not in for x. So 7 minus 2 times x minus 5. And we got to solve this equation. I'm going to start by subtracting 7 from both sides. And then I'm going to divide both sides by -2. That gives me 1 over here. And then I'm going to add 5 to both sides. And I get that x is 6. So the point would be 6, 5. 6, 5. So what I think I'll do is go y equals, I'm going to check my last couple answers here. Punch the equation in. Go to the table. And I can see I get 3 and 11, and I get 6, 5. So there we go. Use the point you named in number 17 to write another equation line in point slope form. So we're going to do y equals, we already know our slope is -2, times x minus our x value, which is 6, plus our y value, which is 5. And since we already have this entered in the calculator, let's put this one in. -2 times x minus 6 plus 5. I'm going to go to the table. And you can see it gives me the exact same values, the exact same outputs for the inputs. So we know that that is the right equation. Solve this equation. All right. Well, how about we multiply both sides by x plus 2. That would give us 5 minus 11 equals 3 times x plus 2. Over here, this is obviously -6. I think I'll divide both sides by 3 now. That'll give me -2 equals x plus 2. And then I'll subtract 2 from both sides. So I get -4. And I think I'll just check my answer, maybe just using some mental math. Like I said, 5 minus 11 is -6. -4 plus 2 is -2. negative 6 divided by negative 2 is positive 3, so I know I'm right. Factored form confused some people, but this was in the chapter review, and also in some one of the practice your skills, but sorry, wait, we're going to write 5x minus 20 in factored form. So this is like 5 times x minus 5 times 4. So both terms have a factor of 5. So what we're going to do is factor that out and make it 5 times x minus 4. That's called factored form. We could put this and our answer into the calculator, and we would see that they are both equivalent. All right, more equivalent equation stuff. Let's write this in intercept form. So the first thing I'm going to do is distribute the 14.7. So 14.7 times x is 14.7x. 14.7 times negative 20 is negative 294. And then we'll add that 130.6. And you get 14.7x minus 163.4. Now we already knew the slope. What if we just entered the original equation in? 14.7 times x minus 20 plus 130.6. And then we went to the table. We could see that the y-intercept right there is negative 163.4. All right, so that's a way you could probably skip this middle step, even though we should know how to do distributive property and combining like terms. All right, so we got this equation, and we're going to write it in point slope using an x value of 8. All right, well, let's figure out what y is when x is 8 first. Again, we could use the calculator as a shortcut for this, both the table or just a home screen like I'm about to do. All right, so that gives me y equals 32.6. So now I can write my new equation, which is going to be y equals 6.2 is my slope, x minus the 8, which is the x value that was given to us, plus the 32.6, which is the y value that we just figured out. Let's go back to our calculator, plug in the original equation, 6.2x minus 17, go to our table, and we can see at 8, we get an output of 32.6. And then if we go back to y equals and we enter our new equation, and then check the tables, we're going to see that we get the same outputs given those inputs. All right, so now we're going to model some situations using equations here. Use the following information. Jamie spent the summer in Canada. Because Canada uses the metric system, he wanted to be able to convert Fahrenheit temperatures to Celsius. So he remembered these relationships, that 32 degrees Fahrenheit is 0 degrees Celsius, and that 212 degrees Fahrenheit is 100 degrees Celsius. Show how he could use this information to write an equation in point-intercept form. So I guess the first thing I'm going to need to do is figure out the slope. So let's do change in y, 100 minus 0, over change in x, 212 minus 32, which is 100 over, I think that's 180, yep, 180. And that can be simplified. So 100 over 180 is a repeating decimal, and that got some people in trouble. Let's convert that to a fraction. It's 5/9, as in 20 goes into 100, 5 times 20 goes into 189 times. So now we can write our equation. We could either go with y equals 5/9 times x minus 32 plus 0, but I'm not going to write the plus 0 because that wouldn't be simplified. Or I can go with y equals 5/9 times x minus 212 plus 100. Those are equivalent equations that will convert Celsius to Fahrenheit. As a matter of fact, I'm going to get rid of the x's and the y's, and I'm actually going to use Celsius and Fahrenheit because they do tell us to use F for Fahrenheit and C for Celsius. There we go. Real world meaning of the slope. How about that? So remember that was change in y on top, okay? And change in x on bottom, or change in Celsius over change in Fahrenheit. So for every 9-degree change in Fahrenheit, the Celsius temperature would change by 5 degrees. Now, if you put this in a decimal, it would be a little bit different. Or you could say, I guess, that for every 1 degree Fahrenheit change in Fahrenheit, the Celsius temperature goes up 5/9 of a degree. But I think since it was already written as a ratio, I'll use those two numbers. Use your equation to find the Celsius equivalent of 68 degrees Fahrenheit. I think I'll use this purple equation. That's the easier one to use. So, all right, let's go 5/9 of 68 minus 32. So 68 minus 32 is 36, and we're going to multiply that by 5/9. That gives us exactly 20 degrees Celsius. By the way, you could Google this and you would get that answer. I mean, you could just type in what is the Fahrenheit or Celsius equivalent of 68 degrees Fahrenheit. It'll flat out tell you that, but your equation will as well. On a warm day, the temperature is 40 degrees Celsius. What is the Fahrenheit equivalent? So let's go Celsius equals 5/9 times Fahrenheit minus 32. So here's the way I think, oh wait, I gotta put in my value here, which is 40 degrees. There we go. So I think I'll do multiply both sides by 9. Let's do it in a couple steps. 40 times 9 is 360. That would give me this as a result. And then I'll divide both sides by 5. That would give me this. And then I'll add 32 to both sides, and that'll give me 104 degrees Fahrenheit. So yeah, that is a very warm day, 104 degrees. All right. Isabel, a research assistant at Maryland State University Museum, measured the metacarpal 1 bone, the bone from the wrist to the thumb, okay, and the height of human skeletons. Anthropologists can use data such as these to conjecture a person's height based on partial skeleton remains. Cool. Use your calculator to make a scatter plot and describe the window we use. Well, I already put the data into my calculator. List 1 is the metacarpal 1 length in millimeters. List 2 is the skeletal height in centimeters. I just need to turn on my scatter plot. Let's clear my other equations off. Let's go zoom 9. There's my scatter plot. And if you check the window, you can see that we want probably choice D there, from 30 to 60, and from 150 to 190. That'll include everything. So choice D. All right, find the 5-number summary for the metacarpal 1 length data. All right, so I'm going to go back to my main screen. Let's go stat, calculate, one variable stats for list 1. That's where I put my Metacarpal 1 data. Scroll to the bottom. 39, that's my smallest value. 42, 45.5 is my median. 50 and 52. Notice that my X minimum and my X max are smaller than the 39 and bigger than the 52. All right, 5-number summary for the height. Let's run one variable stats again, but this time for list 2. Scroll down to the bottom. There's our numbers: 157, 169, 172, 176, and 183. Again, our Y minimum and Y maximum for our window, smaller than the 157, bigger than the 183. Coordinates of the Q points. All right, so the Q points, since this is a graph that's, as X is increasing, Y is increasing, we'll use Q1 of X and Q1 of Y. So that's 42, 169. And then we'll use Q3 of X and Q3 of Y, 50, 176. Those are our 2 Q points. Slope of a line that runs through those points. Okay, and let's go 176 minus 169. There's my change in Y. 50 minus 42. There's my change in X. That gives us a change of 7 over 8. That's our slope, 7/8, or 0.875, I guess, if you want that. Real world meaning of the slope. So change in Y, skeletal height, over metacarpal height. So let's go this. For every 8 millimeters of metacarpal, let's do this. Each time the metacarpal 1 length goes up 8 millimeters, the skeletal height goes up 7 centimeters. Equation of the line through the Q points. Well, we already, shouldn't be too tough for us. We've already got the slope and we got some points. So here we go. We could do Y equals 7/8 times X minus 42 plus 169. Or we could do Y equals 7/8 times X minus 50 plus 176. Those are the same equation. I guess you could turn those into point slope form too. Let's see, Y equals 7/8 times X minus 42 plus 169. Let's go to the table. Let's get our y-intercept. So there we could go, or y equals 7/8 times x, times x plus 132.5, or the 132.25. All of those equations would be the same thing. All right, 34, graph the equation that we just wrote in the same window as the scatter plot and sketch the result. Do you think the line is a good model for the data? Let's graph it. Ooh. Well, I see half the points above. There's 3 or 4 above, and there's 3 or 4 below. Goes through our Q points, but I don't think it's a good fit, okay? This model is not a good fit for the data. I'll tell you why. Even though half the points are above the line and half are below the line, it doesn't, how about comma? it doesn't fit the trend of the data. It needs a slightly greater slope. How about that? Let's see. Let's run this real quick here while we're here. Stat. Get some bonus footage here. Calc. Let's go linear regression. Using list 1 and list 2. Let's calculate that. So this would probably be a better fit. Y equals 1.73x plus 93.10 would be a better fit. I'll prove it. Let's graph it. Yeah, that fits the trend much better. Lower y-intercept, higher slope, and we get something a lot better there. We should use that one to make predictions as opposed to the flatter one. All right, so there's your notes on the solutions to the second part of the Chapter 4 test. Have a good one, and I'll see you again soon.